All right, let's talk about one of the most powerful technologies out there today, machine learning. We're going to pull back the curtain and really demystify it to figure out what's actually going on under the hood when we say a machine can learn.
You hear the terms AI and machine learning thrown around constantly, right? But it begs a really fundamental question. How can a machine, a bunch of silicon and code, actually learn anything at all? That's the core question we're going to unpack right now.
So, to really get what machine learning is, you've got to first understand what came before it. This wasn't just a small update, it was a massive fundamental shift away from how we used to build systems. It's a move away from rigid, pre-programmed rules to something way more flexible.
For the longest time, programming was all about giving a machine a perfect set of instructions. If this specific thing happens, then do that specific thing. The problem, of course, is that it's incredibly rigid. It can't handle anything the programmer didn't think of ahead of time. Machine learning flips that whole idea on its head. Instead of feeding the machine rules, we feed it data, tons and tons of examples, and we let it figure out the patterns for itself. It's a huge leap from being static to being truly adaptive.
Okay, so if a machine learns from data, how exactly does it do that? Well, it turns out it's not a one-size-fits-all kind of deal. You can think of it like a learning playbook that has three main strategies, and each one is suited for a different kind of problem.
First up is supervised learning. This is the most common type you'll run into, and honestly, that flashcard analogy is perfect. You're basically giving the machine a gigantic data set where every single piece of data is labeled with the right answer. It sees a picture of a cat and it's told, hey, that's a cat. After seeing thousands or millions of these labeled examples, it learns to identify cats all on its own.
And this is where its real power comes into play. In all of these cases, the machine is trained on historical data where we already know the outcomes. It learns the patterns from past equipment failures to predict future ones. It learns from thousands of labeled medical scans to help doctors spot tumors. The key is always the same. It's learning from examples that have a known correct answer.
But what happens when you don't have all that nice labeled data? What if you don't have the right answers? Well, that's where unsupervised learning comes in. Here, you give the machine a massive, messy pile of data. No labels, no answers, and its job is to find the hidden structure. It has to act like a detective, digging through the data to find clues and patterns that a human might never, ever see.
And this makes it incredibly powerful for discovery. A big online retailer can use it to uncover natural customer groups just based on their shopping habits, without defining those groups in advance. Or in a factory, it can spot that one tiny weird sensor reading that signals a huge machine is about to fail, an anomaly that would have been totally lost in a sea of normal data.
Our third and final learning style is reinforcement learning, and this one is all about learning by doing. You have an agent, think of a robot or a game-playing AI, and it learns through pure trial and error. It takes an action, and the environment gives it feedback. It gets a reward for a good move or a penalty for a bad one. It's almost exactly like training a pet with treats.
So it follows this really simple loop, over and over again. The agent tries something. The environment gives it a reward or a penalty. The agent updates its strategy based on that feedback. And then it repeats that loop millions, even billions of times. That's how an AI learns to master a super complex game, or how a self-driving car figures out the best way to navigate a chaotic intersection. It's not learning from a static pile of data. It's developing a winning strategy in a constantly changing world.
Okay, so we've got these three ways of learning. But what's the end game? What do they actually let us do? Well, it all boils down to three core transformative powers that are reshaping just about everything. The first one is predictive modeling. This is basically the ability to forecast the future by learning from the past. It allows us to move from being reactive, fixing things after they break, to being proactive, to anticipating problems before they even happen. That is a huge deal.
Second is adaptive decision-making. This is the ability to think on your feet, so to speak. A system with this power doesn't just follow a fixed set of instructions. It responds to new information in real time. Think about a self-driving car adjusting to sudden traffic, or a smart grid rerouting power during a surge. That is adaptive decision-making in action.
And finally, maybe the most powerful of all is continuous learning. This means the system doesn't just become obsolete the day it's deployed. As it gets more and more data from the real world, it can update itself, refine its understanding, and just get smarter and smarter over its entire lifetime. It's the key to building systems that actually last.
Now, as incredible as all this sounds, it is not magic. And we have to be real about this. Deploying machine learning in the real world comes with some really serious challenges and risks that we absolutely have to consider.
Look, these models are only as good as the data you feed them. Garbage in, garbage out is the absolute law of the land. They can also overfit, which means they just memorize the training data instead of learning the general patterns. And a lot of them are black boxes, making it almost impossible to know why they made a certain decision, which is a huge problem in high-stakes fields. And crucially, they learn from our data so they can inherit and even amplify the biases that are already present in society, leading to really unfair outcomes.
There's a quote from the source material that really just hits the nail on the head. It says that the journey into machine learning is both intellectually rewarding and practically urgent. And that really captures this moment. Getting this right isn't just some interesting academic puzzle anymore. It's a practical and urgent necessity for all of us.
And that leaves us with one final, vital question. A machine can learn to spot patterns, make predictions, and pick the best action. But what it can't learn from data alone is responsibility. It can't learn ethics. So as these systems become more and more powerful learners, our role as their teachers becomes more important than ever. What do we teach them? That is the challenge ahead.